Hi everyone, this is Mrs. G, and today we're going to learn how to graph rational functions. But first, I have a quick warm-up for you where you will be making the parent function 1 over x. So please pause the video and give that a try. All right, go ahead and check your work here. So first, check your table of values, and notice that here we do have one value that does not exist. You cannot divide by 0. So this you should have does not exist. And remember, if you're dividing by a fraction, you simply multiply by the reciprocal. So dividing by -1/2 is like multiplying by -2. So if you go to plot these points, you'll see that as I travel along to the left, my points are getting closer and closer to the x-axis, but they're never quite reaching it. And if I travel closer or farther along to the right, I'm getting closer and closer to the x-axis, but from above. But I will never quite reach it. So that's why you see here that I added in this horizontal dotted line. So these graphs have a horizontal asymptote, and the parent function, it will have it at y equals 0. So please add that into your graph. Now another thing you'll notice is that as our x values get closer and closer to 0, the y values get farther and farther away. So you can see that like I'm going to travel along my y-axis going up and down forever, but I will never quite touch this line because remember, x cannot equal 0. So these graphs also have vertical asymptotes, and for the parent function, it's at x equals 0. So this is the general shape that all of our functions that we're graphing today will look like. We call this a hyperbolic shape. It's kind of like two parabolas in one graph. And these functions, again, are going to have both horizontal and vertical asymptotes, at least for the basic ones that we will be learning to graph. So we have to remember that when we're graphing these to include that feature and to look out for ways that these features can change. So rational functions, first, it's important that we know what they are. Remember, rational is just a fancy math way of saying fraction form. So it's simply a function that's in fraction form where p of x and q of x are just both polynomials and our denominator cannot equal 1. So it's just where you have a fraction and we do have x in the denominator. So this again is our parent function as we just did in the warm-up. And we do have that vertical asymptote at x equals 0, which I would like you guys to always sketch in with a dotted line. And we have a horizontal asymptote at y equals 0. And then we'll see that hyperbolic shape again. And it's for us, for again, basic rational functions, these are always going to be opposite each other. So either be up in the upper right and lower left, or sometimes if there's a reflection, it will be in the upper left and lower right, but they'll always be across from each other. So today we're going to learn how to graph these with transformations. So this is the transformation form of our rational function. So it's really important that you get comfortable with this form. So if you compare this to what we were just working with, which is just 1 over x, you can see that if you have a number on top, it's an a value, it's going to be a vertical stretch or shrink. If we're adding or subtracting to x, which would be in the denominator, it's going to be a horizontal translation, so it's going to shift our graph left or right. And if we're adding or subtracting to the entire function, it's going to be a vertical translation, which will shift our graph up and down. So as we talked about, these graphs have both horizontal and vertical asymptotes. So when we're graphing these functions, the first thing I do is actually figure out where the asymptotes are. So if we have a vertical asymptote, which again, the parent function, it starts at x equals 0, only a shift left or right can move it. So whatever your h value is, and notice it does say x minus h, x equals h will be your vertical asymptote equation. So if it says x minus 2, it's shifting our graph to the right 2, so it's at x equals 2. And then this vertical shift will move any horizontal asymptote, so it will shift your graph up or down by k units. So h and k are going to help us dictate our asymptotes. And once we have those, we're simply going to plot points to the left and right of the vertical asymptote. So I'm going to pick an x value to the right, an x value to the left, and then once I know that I'm in the correct area, I can just sketch in the general shape. I know that these will follow along the horizontal and vertical asymptotes, and I know the general shape they make, so that will be accurate enough for our purposes. So again, just a reminder, when we see this h here, h is a horizontal translation, which will shift the vertical asymptote. Right? If I have a vertical line and I shifted it up or down, it wouldn't change. But if I shift it left or right, it does. And then just a reminder, the K is a vertical translation, which is just a shift. So that will shift the horizontal asymptote. Again, if I have a horizontal line, only a shift up or down will move it. So this is the process that we will be using today to graph these basic rational functions. All right, let's give this first one a try together. So we are still going to describe the transformations that we see just to maintain that skill, and then we're going to graph it on the axis below with our asymptotes included, and we're going to also write in the asymptote equations. So first, if you compare it here to here, you'll see that there's an a value equal to 4. So that's going to simply be a vertical stretch by a factor of 4. So you'll notice that there are no translations. So there's no h, well, h is 0 and k is 0. So that means that our vertical and horizontal asymptotes are not moved. They're going to be in the same place as our parent function. So y equals 0 and x equals 0. And remember, please always draw in asymptotes as dotted lines, and let's label the equations as well. All right, so now we're going to find a couple exact coordinates. We need at least 2 here, but this is a pretty basic function. Maybe we'll find a couple points to the right of our vertical asymptote and a couple to the left. Okay, so let's plug in x equals 1. Let's find f of 1. Again, I'm plugging it in right here. 4 over 1 is simply 4. So I have the coordinate 1, 4. I can plug in 2 pretty easily because 4 divided by 2 is 2. And if I'm picking the x values, I'm not going to pick 3, but maybe I'll pick 4 because 4 divided by 4 is 1. So I also have the coordinate 4, 1. And I know that my graph will travel along both my horizontal and vertical asymptotes, so it ends up making a shape like this. And now we're going to pick a couple x values to the left, maybe -1, so that would give us -4. So -1, -4. Maybe I'll also pick -2. So 4 divided by -2 is -2. So there's another coordinate. And again, I'll pick values that seem easy to plug in, so I'll also pick -4. So I get the coordinate -4, -1. Again, I won't always find this many exact coordinates, but you can always find more coordinates to add accuracy to your graph. And then I know, again, that it will hit those coordinates, but then it will start traveling along my horizontal asymptote and my vertical asymptote. And I'm done. That's all there is to it. All right, let's try this next example together. So here I see 2 transformations. First, I see a negative, and I see that it's on top. We're always going to just put the negatives on top, and that means that I'm multiplying the entire function. It's kind of outside, so it's going to be a vertical reflection, which is going to reflect over the x-axis. So I have a reflection over the x-axis. And then I also see this +2. So remember, this is a horizontal translation. And it's going to shift my graph to the left 2. So since our graph is shifted to the left, we know that our vertical asymptote, which used to be at x equals 0, will also shift to the left 2. So I have a vertical asymptote at x equals -2. However, I do not have any shifts up or down. There's no vertical translation. So my horizontal asymptote will remain at y equals 0. So now let's plug in a couple points to the right and left. So let's plug in some points to the right of -2. I can do -1. So we have -1, I can show this out, divided by -1 plus 2 is -1 over over +1, which gives us -1. So I have the coordinate -1, -1. So it's going to be down here. So since I have a coordinate down here below my horizontal asymptote, I know that my graph is actually going to do this. So it's going to still follow along our asymptotes, but instead of being up here in the upper right, it's going to be down here in the lower right, which means I can guess that the other one will probably be in this area, but we're still going to plug in an additional point just to make sure. Let's plug in -3. So we have -1 over -3 plus 2, which is -1 over -1, which is +1. So we have the coordinate -3, +1. And again, I know what my graph will do from here. It's going to travel along the asymptotes. And you can see that it is in that opposite quadrant. So that tells us that our coordinate is probably correct. So you'll see whenever we have that reflection, instead of being up here and here, our graph is going to fall in the other two coordinates. All right, let's try one last problem together. So here I see that 2 for my A value. So I know that's going to be a vertical stretch by a factor of 2. And then I see this +1. Now, since it's not specifically grouped with x, I know this is a vertical transformation. So it's going to be a vertical translation up 1. So since my graph is being shifted up 1, that means that my horizontal asymptote will also be shifted up 1. So it'll become y equals 1. But since my graph is not shifted left or right, my vertical asymptote stays at x equals 0. So now we're going to plug in some points to the right and left. Let's do f of 1. So I have 2 divided by 1, which is 2, plus 1, which is 3. So the coordinate 1, 3. And I think +2 is a pretty nice number to plug in as well, because we have 2 divided by 2, which is 1, plus 1 is 2. So we have the coordinate 2, 2. I think that's pretty good. Let's connect the dots and travel along the asymptotes. So it'll look generally like that. And let's plug in a couple points to the left of our vertical asymptote, maybe -1. So that would give us -2 plus 1, which is -1. So -1, -1. So right here. And let's also plug in -2. So that would give us -1 plus 1, which is 0. So I have the coordinate -2, 0. Again, I'm just going to go through my coordinates and travel along the asymptotes to make the general shape of our graph. And even though we only have a couple exact coordinates, this is still a pretty accurate graph. So it doesn't take much for us to get there. And again, when you're plugging in points, pick nice numbers. Look at what you have going on in your function and be strategic with the x values that you choose to plug in. All right, at this point, I'm going to ask you to pause the video and give this problem a try on your own. All right, go ahead and check your work here. So we do have 3 transformations. We have a reflection over the x-axis, vertical stretch by 3, and a vertical translation down 2. So that shift down will move our asymptote to y equals -2. The vertical asymptote is unchanged, and then I simply plugged in a couple points to the right and left. Notice I picked 1, and then also notice I picked 3 because -3 divided by 3 is a nice value, and then I also picked -1 and -3. So just make sure you're being strategic, again, with the x values that you pick. All right, here's the last one for you to try. So again, please pause the video and give it a shot. All right, go ahead and check here. We do have a horizontal translation to the right 4. So you can see that our vertical asymptote has also been shifted to the right 4. And then we have this vertical translation up 3. So we can see our horizontal asymptote has been shifted up 3. And then I plugged in x equals 5 and x equals 3 to get these two coordinates. And again, we only need at least 2 exact coordinates. So once we know which quadrants we're working in, we know the general behavior of our graphs. So we're good to go from there. All right, that is all for today's video. Thank you so much for watching.